Hello students, welcome again in the chapter of derivative. First order derivative and second order derivative related in our last exercise 5. Yes students, today we going to all numericals are very most IMP. Yes students, almost all numerical are most IMP numerical for bold level. So very carefully you write down in your notebook. Question number 12th one. I going ahead. Y given 12 1 minus cos t and x given 10 t minus sin t in condition minus pi by 2 to pi by 2 and find out our dy by dx. Yes students, very easy. dy by dx I converting into parametric form t and then after I going to first order derivative dy by dx. So first start differentiation with respect to x. No, you can't write down here x because here t is variable. So first I am going to respect to t and then after I start dy by dx. Yes, so first steps here dy by dt constant outside d by dt of 1 minus cos t, 1 derivative constant 0 and sin t derivative cos t derivative minus sin t. It means you have to only 12 sin t. Continue dx by dt. It means this data I convert into respect to dx by dt. Then d by dt of t minus sin t. It again 1 minus cos t. Now, what is 1 minus cos t? Yes, you know that it is a trigonometric formula which is 2 sin square t by 2. And finally, you did dy by dx. It is dy by dt upon dx by dt. And what is the dy by dt? 12 sin t by 10 into 2 into sin square t by 2. Yes students, this cancel 2 6 and this sin t formula again you know trigonometric formula first formula which is 2 sin t by 2 cos t by 2 and upon as it is. So here numerical done. 1 sin 1, 2 5 are gone. I have only 6 by 5 cos t by sin t by 2. It have to easily that I know cos t by 2 by sin t by 2. Yes, which is cot t by 2. And here our first order dy by dx. Students, easy done. But if you given your parametric t, you first write down the t terms after that dy by dx. Yes students, here this numerical is over. Now students, after ending I am going to one more numerical, question number 13. Question is there, if y is equal to sin inverse x plus sin inverse under root 1 minus x square and condition given 0 less than x less than 1, find dy by dx. Yes students, this numerical I explain you two different ways. One of the condition wise I explaining you and one of the without condition. Both of you IMP. So for condition wise, look at that. 0 less than x less than 1. You necessary check. This 1 minus x square is lies the condition in sin inverse. It is positive or negative. So I just made first of all square multiplying minus 1 on both the side. Inequality change. And one addition here 0. 1 addition, here 0. So you get to 1 to 0. It means 0 to 1. Check. It is true for the legal range that sign function. Positive, yes. That's why I just write down my further steps. It is very easy. So my question is that now I start that 1 is equal to sine inverse plus sine inverse under 1 minus x square. It is purely cos inverse x because it lies in this range. And here same is, and that's I know pi by 2. So what is the differentiation? 0. Over here something. But condition given, that's why. But the same question I explain you by different concepts. Look at that. Here extra. You write down necessary in your notebook. This is the board question. Sine inverse x plus sine inverse 1 minus x square, and only asking find dy by dx, not given condition. So you never write down this one because here no are the different answers also possible. A direct start differentiation with respect to x. So what is the dy by dx? d by dx of first data and d by dx of second data. I only direct derivate if you condition not given. So dy by dx, this derivative known very well, 1 by under root. Here also 1 by under root 1 minus x square. In the interval, this data is this. And dx of which derivative is pending? Under root 1 minus x square. So you getting just only here 1 by under root 1 minus x square. Here again 1 minus 1 plus x square. Root and square cancel. And here are root derivative first. After that internal term derivative. So 1 by 2 times. Here 0. X square is 2x. 2 cancel. 1 cancel. Now one turning point coming here, students. It is a easy. One turning values are dy by dx. It is 1 over under root 1 minus x square. Under root x square. And into minus x by under root 1 minus x square. Students, here what is the value of under root x square? Yes, they may be positive, may be negative. That's why I written here. It is modulus. Yes, students, that is the main difference to condition wise separation. And here I start our case number 1. If x more than 0, it means positive. It means you also write down that 0 less than x less than 1. That is your textbook question that. Yes, student. Here running your answer is 0 definitely. Modulus of x positive. So what is the answer? My answer is here x minus x by under root. Look at that. This cancel. Further value also cancel. My answer is 0. Check. You did this answer. And this case already I explained you. 0 less than x less than 1 condition, direct cos inverse x. Condition given, that's why here not given, but answer is coming. Now second concept, case 2. If x is less than 0, it means minus 1 less than x less than 0. It is negative side of 0 then. So this range for the value modulus x minus x. You know why I write here minus 1 and 1? What is the range of sine function? Close bracket minus 1 to 1. No, that's why. And this answer minus, I written the minus x. dy by dx, same right, under root 1 minus x square, but here write down this one is a minus x. Other same, by under root 1 minus x square. Check. Cancel, cancel. Minus, minus, plus. So your answer is 1 by under root. 1 by under root. It means your answer is 2 by under root 1 minus x square. This answer is also true. And that's why saying the condition is not given, but you explain by that both cases. Clear? Yes. Here our this numerical is done. Now I am going ahead to next one. Now students, I am going ahead slowly. One more question. 14th one, which is also IMP for exam level. So this also you highlight most IMP. Yes. Find out dy by dx minus 1 by 1 plus x square in this condition and function given. Very easy students. First time calculate y value one side and x value one side. So can we write down this are right side minus y and taking square on the both side, because I want y value separation. So here x square 1 plus y square 1 plus x. It's very easy. X square plus x square y square plus y square x. These two are to combine and these two are to be combined. So x square minus y square plus x square y minus y square x. You just only take common. Here are two factors, x minus y, x plus y, and here common xy. Yes, remaining are x minus y. And common check. What is the common? These two are the common. Remaining are x plus y plus xy. And here students, you can create two different values. First value, x minus y 0. Or another value, x plus y plus xy 0. Yes students, here x is equal to y. Derivative view. This answer is not you prove that. So I further calculate. And here common checking y. So remaining are 1 plus x. Surely x is equal to minus y. So what is y? Minus x upon 1 plus x. Students, this one. Look at that. Y separation. Now I start derivative respect to x. Differentiation with respect to x. So here dy by dx. And here minus ddx of. I just go to division rule. You know that? Yes, the 1 by 1. I apply division rule. Dy by dx. That's why it is same as 2 minus same. And here applying our division values. So it is a division rule. Denominator square. Now denominator ddx of numerator minus numerator ddx of denominator. And here expansion, sure students, you getting your final answer. So dy by dx, it is the minus 1 plus x derivative 1 minus x, here 0 plus 1 upon as it is. So finally, you getting the value here 1 plus x minus x. Check. X and x 1. Then your answer. And 1 plus x whole square. That you finished here this. Yes students, here this part is happily over. Now students, I am going one more dangerous sum. It is the most IMP sum. Prove that in this level, first order derivative, second order derivative, and by 2 is a constant and independent of a and b. It means not dependent a and b for these equations. This equation is student nothing. It is a Cartesian equation of circle. And this equation have I start my first statement number 1. Because it is utilized till end, differentiation with respect to x. Here ddx first, ddx second, and here ddx of our c square value. Here as it is x minus a whole square, y minus b whole square, and one by one start the derivative. So here derivative is what? 2x minus a. X derivative 1, a derivative 0. Same, 2y minus b. Y derivative dy by dx. But b derivative 0. Here also 0. Because constant. So 2 into x minus a is 0 minus 2 y minus b. So what you getting? Final dy by dx. First step x minus a upon y minus b. Here our stop for statement number 2 because that I utilize here. Now I go to second one. So differentiation with respect to x again. So d square y by dx square. But here d dx of our full data just applying one by one to derivative. Yes, students. Here I go to d square y by dx square and minus that apply division rule. So denominator d dx of numerator minus numerator d dx of denominator and upon what is upon denominator square y minus b the square. Now d square y by dx square which have to y minus b. Here start the derivative. X is 1, a is 0. Same. Look at that. Y derivative dy by dx. But b derivative 0. And upon again I change the same. Now students this dy by dx. Already you know. Apply that. So d square y by dx square y minus b minus of x minus a, and this value actually collect from here minus 1 into x minus a by y minus b upon y minus b the whole square, and declare here from 2 because you apply the second equation number. Now look at that, minus minus plus, LCM multiply here and also multiply it by minus b. So my value is y minus b square plus x minus a square upon by whole raised to cube. Y cube, this square and this LCM, the multiply. And students, these two values already known that equation 1. So this data actually I put down the c square. So here c square by y minus b is to 3, and here declare it is equation number 3rd. Now students I start after that is half numerical final calculations. So my calculation is there. Value for derivation, this value, and I prove it is a constant anyhow. Now I value is 1 plus dy by dx whole square by d square y by dx square. And so does this value to respectively apply 1 by 1. So these are known u minus x minus a by y minus b, and that is the square raised to 3 by 2 same, and upon second order is that c square by y minus b the cube. Here mention from 2 and 3. Yes students, now it's very easy. Take out LCM. So minus, here LCM are y minus b whole square, x minus a whole square upon y minus b whole square raised to upon same is. Now students, again these are what? It is statement 1, c square. So I value is c square, y minus b whole square raised to 3 by 2 upon same as. Now this 3 by 2 apply the power difference. It is c cube y minus b cube upon. These are the final our solutions. So students, after that you just only 3 by 2 cutting. It is 2 to only 3 cutting, and this also cutting. You have to only minus c. In short, it is independent of a and b. It is independent of a and b, and it is a constant. So sometimes proving it is a constant, either independent of a and b. Yes students, here our this 15 question is happily done, but it is an IMP question, sir. It is an exam level questions. Now I am moving ahead to 16C. Same as is a big numerical ending. Other also IMP sums. If a given cos A is equal to cos y is a x into cos A plus y with cos A not equal to cos A minus 1, then prove that yes, what we prove, dy by dx is equal to cos square A plus y by sin A. Yes, this numerical also students IMP for 3 marks. Yes students, I want the cos square A plus y by sin A. So necessarily y value separate one side. So this x I just dissolving. Separation cos y upon cos of A plus y. And here start differentiation with respect to what? Respect to x. So d by dx of x. Here also d by dx of cos y below cos of A plus y. And here students, start your derivative respect to our x. It is 1. Here denominator d by dx of numerator. I apply division rule. Denominator, numerator derivative minus numerator, denominator derivative, and upon denominator square. So does this square, it is your answer, one of the parts. So these are multiplied here. Cos square A plus y, and here cos A plus y. Now what is the cos y derivative? Yes, minus sin y, and y derivative with respect to x, which is dy by dx, minus same as cos y. Here cos derivative again minus sin, and internal here 0, but y derivative dy by dx. Finally this dy by dx, and that You take out common outside. So remaining are cos square a plus y. Here dy by dx I just take out common. Remaining are minus cos a plus y sin y plus cos y into sin a plus y. And now here students, it is a rearrangement. Sure, it is a formula. So my further steps, cos square a plus y is a dy by dx, and other just rearrange. First positive, second negative. So positive value I have cos y sin a plus y minus cos a plus y sin y, and that is a perfect square. Yes students, it is perfect square. Sorry, my mistake. It is not a perfect square. It is a perfect formula for cos alpha sin beta minus cos beta sin alpha, which is formula for finally, which is sin a plus y minus y. I mean alpha beta minus beta formula, and this cancel. So finally students, what you get? You get in the cos square a plus y by sin a, and check. That's your final proving. It's very easy and very simple. Yes, but this step is main step for deriving that. Yes students, here like our last. Now I go in next one. Now students, one more question 17, which is also IMP for exam. So you tick mark again, which is most IMP. Yes students, before starting this part, I already told today all numerical are most IMP. And all numerical I explain slowly. Okay? So here also asking respect to t, but discover dx square. So first I find out t respect. After that first derivative and then second derivative. So first of all, differentiation with respect to what? T, because t is your parametric given. So dx by dt, we have a d by dt of cos t plus t sin t. And here students, I just start the derivative. So dx by dt, a, what is the cos t derivative? Yes, you correct thing, minus sin t. And here, first, second order, second, first order. So sin t here, that is the t. So dx by dt, you getting only minus sin t, t. Now sin t derivative respect to t, which is cos t. Again, here t respect to t, 1. And that's the cancel. Only and only getting dx by dt here, a into t into cos t. Students, here first part is that. Now I am moving ahead to y. So, what is the y? A into, that's one. Sin t minus t cos t, and start the divide by dt respect to t, your derivative. d by dt of sin t minus t cos t. So finally you getting here sin t derivative cos t minus. This is a main point. Generally students mistakes here. Minus outside. So bracket must be taken. First, second derivative plus second, first derivative. Now direct 1 by. So dy by dt, we have to cos t same minus t. What is cos t derivative? Minus sin t plus again cos t. Here 1. And now expand the all. So dy by dt a into cos t. Students, here just I'm expanding. Here minus minus plus t sin t minus cos t. That's cancel. You have to only a into t into sin t. Now students, this both carry in the first order derivative. So what's the dy by dx? dy by dt upon dx by dt. In both value I know. That's the dy by dt. A t sin t. And what is the dx by dt? A t cos t. Yes. Cancel. So my final dy by dx, which is tan t. Students, here you success for first order derivative. Now I want second order. So differentiation with respect to what? And second order derivative must be. So d by dx, here dy by dx, but here tan t. So we getting d square y by dx square. Here tan function derivative first, after that t derivative. So tan is a sec square t and t is a dt by dx, and this value actually coming here. dx by dt is a reciprocal of that. It is dt by dx. So d square y by dx square, we have to sec square t. And what is dt by dx? 1 upon a t cos t. And what is a cos t derivative? I mean reciprocal, sec t. So this sec is sec square t, which is sec raised to 3. Reciprocal, 1 by cos. This is 1 by cos. And this is sec square t, I mean sec t. And this sec square t, it becomes sec cube t. And here students, for the second order derivative, for the 70 questions, is it done? Yes students, it is an IMP sum. Now, yes students, here up to 17 in this part I completed today. Further explanation students, I explain you this example and exercise and miscellaneous example, and then after students I explain you our missing exercise 5.8, which have to mean value and Rawls theorem. This is a different topic, but I explain you next part. Okay, bye bye, see you.